Hello everyone, today we will backtest the London Breakout system in Python. So first, to explain how the system works is during the Asian session we will define a range. So here we can see the upper range during the Asian session and the low range. And then when the London market opens, if the candle breaks outside of the range, that would be our entry signal. So in this case we would buy, and in this variation of the strategy we will close a trade at the end of the European session. So let's now jump to the Jupyter notebook to backtest this strategy. So in order to start backtesting, we will need historical data on GBP JPY, and I have prepared a CSV file which you can find here, which is GBP JPY am15.csv. So to open that file and save into data frame, we will import pandas as PD. And then we will save it into a data frame using df is equal to pd.read.csv. And we now have to enter the file name, which is gbp jpy underscore m15.csv. So now let's look how the data frame looks. And this is the data frame. In this section, I have visualized the OHLC data that we have saved in our data frame, and I have used the Plotly graph objects library where I simply passed the time column on the x-axis and then the open, high, low, close data, and this is the result. So now that our data is ready, let's calculate the high and low of the Asian session. So first, let's take our time column and convert that to a datetime object. So we will convert that using pandas.toDateTime, and we'll pass in the same column. So now that this column has been converted to a datetime object, we can extract the hour property from this column. So to save that hour data, we can simply create a new column. So df hour is equal to df time, and we simply have to extract the hour property. So now we know, for example here, which hour it is. So in order to now get the session, we can create a simple function which will return Asian session if the hour is between 0 and 8. So what we can do is, let's create a function called define get session, and the input of this function will be the hour integer, and simply if the hour is greater or equal to 0 and is less than 8, then we return the Asian session. Otherwise, we can return none. So let's apply this function to the hour column, and then we can create a new column, df session is equal to df hour, and we apply the function that we have just created. So let's apply get session. All right. So now we see that the function works. So if the hour is between 0 and 8, we will return Asian session. So now that we have our session defined, we also need to define the minimum maximum value for each session. So to do that, we want to create a new date column. And this date column will be calculated using the time column, and we simply have to use the datetime property date. So let's see what it looks like. And now we have the date, and in the next step, what we're going to do is we're going to calculate the minimum maximum for each day. So we can do that by df by date is equal to, we take our data frame df dot group by, and we have to group by the date and the session. And to calculate the minimum and maximum, all we have to do is we have to use the ag function, and we are going to calculate the session high, which is our high column, and we apply the maximum for that column. And for our session low, we use the same principle. So we take our low column and apply the minimum value of that column. So let's see what this data frame looks like. And let's see, I forgot a comma at the end. We see the date, the session, and the maximum and minimum of that session. Also, let me remove that index and put it up here into the column, so I can simply add the parameter as index is equal to false. And now I created a data frame without index. So let's visualize the high and low on the candlesticks down here. Now that we have our session high and low defined, we can add this data into our initial data frame that we've created, and we can do that by merging. So df is equal to df dot merge, and here we take our df by date data frame and we merge on the common columns, which would be the date and the session. So we would provide on is equal to date and session in a list, and the type of join we would do is a left join, because we want to keep the data of this data frame and only extend the data for the session high and session low of the Asian session. So let's have a look, and we see that we have successfully merged the data. In order to visualize the high and low, we can simply add a new trace. So with our existing figure, we can add a trace by typing fig.add underscore trace, and we will add a go.scatter trace, and here we will just create a name for this trace, which is Asia high. And then we will have to provide the time data on the x-axis, which would be df time column, and for y-axis we will provide df session high column. For the low, all we have to do is add a new trace. In the new trace, we will, instead of high, call it the Asia low, and here we will have to provide the session low data. So let's see what it looks on the chart now. So here you can see the two traces visualized. So we have the low and the high of the Asian session. Let me just make a small adjustment, as I'd like these lines to span over the entire day so we can monitor the breakouts when we start backtesting. And to do that, we simply have to delete this session data here. So we will simply add the high and low for the entire date column. So here's the result of this change. So we see that the high and low is spanning through the entire day. And for example, in this case, we can see a breakout. So this would, for example, be our buy signal, and we would hold the trade until the end of the European session. Now that our data has been prepared, let's start with a backtest. And I've written down the strategy rules. So the allowed entry is between 8 and 12 after the M15 candle close, which breaks out of the range. The second rule is we will close a position if the price falls into the middle of the range. So for example, on this chart is if we, for example, broke up here, we would close the position here in the middle. And the last exit strategy rule is that if the trade lasts longer than 1700, we will close the trade as this is the end of the EU session. So I'm going to calculate the stop loss now. So for each day, the stop loss would be in the middle of the range. So we can simply create a new column stop loss. And that is equal to the DF session high. And then we simply subtract the half of the range span. So that would be the session high minus session low divided by 2. And we can verify that by plotting the stop loss in the chart here. So let me do that. Alright, the chart has finished loading, and here we should be able to see the stop loss if we zoom in. And as you can see, we have successfully calculated the middle of the range, which should be our stop loss. For a backtest, we will need a data frame of trades. So I'm going to initialize a new data frame, which I will call trades. And to initialize data frame, we simply have to type pd.dataframe. And I'm going to specify the columns for this data frame. So first, we are going to create a column state, which will tell us if the trade is still open or closed. We're gonna create a column order type, which will tell us if it's a buy or a sell order. Then we will add a column open time and the open price, which will tell us when and for what price we've opened the trade, and the same columns for close time and close price. So let's have a look at this newly initialized data frame. And I made a small typo. Data frame should be capital F, and we see that the data frame has been initialized. To run the backtest, we need to iterate over our OHLC data frame. So I'm going to create a for loop for I, x, then we type in df.iteros, and what iteros does is it will create an iterator for a data frame with I as the index and x with the data containing that row. So just for you to see what it looks like is if we only display the last 10 values of the data frame by adding tail 10, and let's see what happens if we print I and x. We see that 69,228 is the index and x is this part here with the data contained in this row. To start our backtest, we will need to create a data frame of trades, and here I've initialized an empty data frame with the following columns. So the column state tells us if the trade is open or closed. The column order type tells us if it's a buy or sell order, and then we have the open time, open price, close time, and close price of that trade. And so let's now proceed with the backtest, and we'll start with the opening conditions. So the first opening condition is that we are only allowed to trade if it is greater than 8 o'clock and less than 12. So our condition, or our open condition number 1, is we can check our data frame with open, high, low, close data and check our hour column. So if x.hour is greater or equal to 8, we can open it, but at the same time it must be less than 12. And the second opening condition is that we do not want to open any new trades if there is a trade open already. So you can see that we have created the trades data frame for a reason, and if we open a trade, it will be added in this data frame, and if the state of a row is open, it means that we have an open trade and that we shouldn't trade. So first, how do we get the number of open trades? And we can get that by taking our trades data frame, which is currently empty, but will be filled during the backtest. We will check if we have any trades that have the state open, and to check the number of trades, number of open trades, we can simply take the shape of the data frame and take the X value, which tells us how many rows there are. So this is number of open trades. And so to create an open condition 2, we're only allowed to trade if no position is open. So num open trades must equal to 0. So let's now write our trade logic. So let's start with an if condition. So of course, open condition 1 and open condition 2 must be met. And for a buy condition, so we write another end condition. The current open price of a new candle must be greater than the current session high. Which means if the new candle that we have is greater than session high, we should open a buy order. And to add a new row into our trades data frame, we can use this syntax. We take our empty trades data frame currently, and then we locate the last row, which is the length of the data frame. And then we will want to assign values to all the columns. So I will specify columns here. And all we have to do now is we just have to assign a value for this new row that we're creating. So the state of the trade is open because we are opening a trade. The order type should be buy because we broke above the session high. The open time should be the current time, open time of the candle, and the open price should be the current open price of the candle. So we use X open, which is this column here. Because the trade is not closed yet, we don't know the close time and the close price, so we can assign none values for the time being. So this is the logic for the long position, but if you want to sell, we need to create a second logic. So if the open price is below the session low, then we want to open a sell position, and this would be the logic for the other side. So our open trade logic is done, and what we have to finish is the logic to close a trade. So our first logic is very simple. So our first close condition is that if we check the rules, if the EU session is ending at 17:00, we should close the trade. So our close condition 1 is if the hour of the candle is greater than 17, right? So if the hour is 17 or greater, we should close the trade. The second close condition is if we hit our stop loss, and for that we have to differentiate between buy and sell orders. So for buy orders, we can type close condition is number 2. So if the low of the candle, so x.low is less or equal than our stop loss level, then this condition is true for buy orders. So we have to then check in our trades data frame if we have an open buy or sell position. And we can do that by checking checking the order type. So what we can do is we can create a variable called open trade order type, and we check if we have a trade in our trade data frame which is currently open. Every time we will only have one open trade, so we can simply just check the first value of this data frame and see if what order type it is, right? So we check the order type, and now, so if it's a buy, it's a buy. If it's a sell, it's a sell. So if the low is less than the stop loss, then this should be valid for buy orders. And then for sell orders, you can write else. If the high of the candle is greater or equal to the stop loss, then the close condition is also met, right? So this part here is for buy orders and this part here is for sell orders. So now if one of these conditions met, let's write our logic to update the close time and close price of the trade. Also, I forgot to mention another thing. So if the current number of open trades is 0, then we can just skip this logic because there is no trades open. So if num trades is equal to 0, then we can just continue. So let's start with the hour. So if we meet the close condition number 1, then we can update the data frame with open trades. So we can just say trades, and then we can locate all the open positions. So we take trades where the state is equal to open. And now we can just update the following columns. So the column state, the column close time, and then the column close price. We're receiving values. So now they're equal to, and we just apply a list. So if we're closing a trade, the state of the trade is changing to closed, right? So we apply closed. We are closing it for the current time of the candle. And then we are closing the trade at the current open price. So we do X open. On the other hand, if we have the close condition 2, so we have close condition number 2, then we will close the trade at stop loss price. So we can just copy this line here, and instead of taking the open price, if we just see the stop loss, all we have to do is we just take the stop loss price and fill it for that price. And now we can run our backtest, and then we should have generated a full data frame of orders. So let's initialize this and run this. So our data frame with the trades have been generated. So the backtest has been finished. So what's missing now is we have to calculate the profit on that trade, and then we can see if the backtest is successful. So whether strategy is profitable or not. And then after I'm done with that, we will also visualize the trades on the OHLC chart. So to calculate the profit, we have to take our trades data frame, and we have to create a profit column. And to calculate profit, first I'm gonna create a function called define calculate profit, or short calc profit, and I'm going to accept the entire row of the data frame. So first we have to differentiate if the order type is by sell. So if X order type is equal to buy, then we can simply just say that the profit is the close price minus the open price. So we return X close price minus X open price. And let's assume that we are trading one lot on GBP JPY. So we will multiply this value by 100,000. And let's not forget that on GBP JPY, the profits are displayed in Japanese yen. So in order to convert it to USD, I'm going to divide this by 130, which is approximately the amount of USD you'll have in the trade. So I'm just going to add a comment. And then again, 100,000 is the contract size of the trade, which is one lot. So this is the formula to calculate the profit on buy orders, and to calculate on sell orders, we can just say the order type. So if the order type is sell, then we will just return a very similar value, but for sell orders, the profit calculation formula is inverted. So we take the open price minus the close price. So now that the function has been created, we can apply this function to our data frame. So this is trades.apply. We apply calculate profit, and we apply it across the entire row. So we have to specify axis is equal to 1. And let's see how the profits look. So our profit column has been calculated. We see that it's right here. And just out of curiosity, we will visualize the profits on a line chart. So we can import another charting library, which is plotly.express, and we'll import SPX. And to check the profit curves, we can just use px.line to create a line chart. We add the data frame trades, and X would be our close time of the trade, and Y would be the profit. So let's see what it looks like. So out of the 631 trades that we've placed, we see that these are profits that are going up and down, but I would like to see the profits accumulated actually. So what I can also do is I can also compute the P&L curve. So let's call a new curve P&L, and that would be equal to my profit here, and we will just use the CumSum function to accumulate all the profits. So instead of profit, let's take the P&L, and let's check if the strategy is profitable. So I'm very happy to see that in this backtest, we see that the strategy has been profitable since 2021. We see a very nice profit, and if you traded the London breakout with one lot, you would have made around 17,000 USD. Of course, I'm not counting commissions and fees into this backtest, So we can also do that real quick. So let's say that the net profit of the trade, let's subtract $10 US as a commission for each trade, right? So we can, for example, say trade's profit, the net profit is the profit minus 10, for example. So here 10 would be the commission, and instead of profit I would replace that here. And so now let's run backtest again, but we still see that even though we're paying commission, we should have earned around 11,000 USD, which is still a big difference, but it's still nice to see that the strategy is profitable. And so the last step is to visualize these trades that we have gotten the backtest in this OHLC chart down here to see if it's working correctly. Alright, so I've also visualized the past 30 trades on our OHLC figure here, so we can see if the backtest has been trained according to the conditions that we've specified. So let's zoom in and check the trades. So simply explained, what this does is that we're taking the last 30 trades, and if the trade is in profit, then we will create a green line, otherwise we create a red line if it's in a loss. And then we're creating a simple dotted line with the coordinates open time, open price, close time, and close price. And here these are specifications for the line. And for example, what you can see here is that we see a successful breakout during the London Open, right? So here we see the Asian high, Asian low. Here with this candle, right, with this candle close, we enter a trade in the long position, and then we close the trade at the end of the day at 1700. Also, we see that we also have some losing trades, right? So this would be an example of a losing trade where we have broken out of the range. So we have broken our range here, and then price retraced back, and we see that the candle has hit our stop loss here, so we close the trade. So that would be it. So thank you very much for watching. Thank you very much for watching the video. Please subscribe if you liked it, and we'll see each other in the next video. Bye bye.